The blue one is going to be your cost function, and the red or maroon colored one is your revenue function. We want revenue to be above the cost, obviously, right? So that's why they're showing you this one here. Even though their slopes are exactly the same, that's a maximum loss, because you have, even though you have the cost of revenue being exactly the same, the marginal cost of revenue, but the cost is larger. The value of the cost is larger. So when you subtract them, you'll get a negative value. Then we have a nice little break-even point here, and then there goes the cost function goes below, the revenue function is above. And up here at this point, they're equal, the marginals are equal. So anyways, your slopes are equal, and this is when we're going to maximize our profit. And notice as it continues on, you get another break-even point. So over here, they're breaking even again, but the cost goes up, but our revenue is leveling off. At that point, you definitely don't want to be doing business. So they give you the recall. Revenue is R of X, marginal revenue is just derivative, cost, marginal cost, and then your profit and marginal profit. And then also keep in mind that your marginal or your profit is equal to the revenue minus the cost. So your marginal profit would be the marginal revenue minus the marginal cost. But in these parts, we also know that these should be the same, so we should get 0. Because we're looking at the fact that the slopes are exactly the same. So when these two equal, which means that when that we have a maximum loss or maximum profit when these two are equal, or 0, when our marginal profit equals 0. Okay, so let's look at a couple of problems. The values we get on this one's kind of ugly, but we've got a nice little picture that we're looking at. So we really don't have to do a lot of the math because we have the picture. They're going, this guy here is our cost, our revenue. The straight line is our revenue, so we have a slope of 9. And our cost is the one in blue. So whenever they're parallel, which is here, but notice the cost is above the revenue, which means we have a maximum loss at this point. And then over here, we have it here again, the marginal is set, so we have a maximum profit. Now the question is there a production level that maximizes profit? If so, what is it? Well, it's at this point right here, 2 plus square root of 2, which is approximately, and you can throw this in the calculator, it's approximately 3.414. Now I'm going to throw it in the calculator just to double check my numbers. I don't want to be silly me. Yep, 3.414. I had already put it in the calculator. But, okay, cool. We can look at the picture and we can give the answer. But what I want to do is I want to go through the math to give you guys a heads up on what you're doing with the math. So if is there a production level that maximizes profit? Okay. So we need to get this, we need our marginal profit. So we need, remember, profit is revenue minus cost, and our marginal profit is going to be marginal revenue minus marginal cost. So we put these in here. So this one here is going to be 9x minus x cubed minus 6x squared plus 15x. So if I do the derivative, get the marginal profit, I'm going to get 9 minus, still in parentheses, 3x squared minus 12x plus 15. Distribute that negative through, we get 9 minus 3x squared plus 12x minus 15. Combine like terms, and our marginal profit is negative 3x squared plus 12x minus 6. Negative 15 plus 9 is going to give you minus 6. But remember, I was telling you on the other page, what we're looking for is when these guys are 0, when this here equals 0. So we want negative 3x squared plus 12x minus 6. We want that guy to equal to 0. So I have a common factor along here of 3. So I'm going to divide each term by negative 3. And that gives me x squared minus 4x plus 2 equals 0. A little bit easier to deal with, but you guys remember we've got to be able to factor really quick. So since this is 1, I'm looking for factors of 2 that add up to 4. I can't get anything like that. So we're going to use, not Pythagorean, we're going to use a quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And this would be ax squared plus bx plus c, for those of you who don't remember that. So x equals negative b, well, b is already negative, so it's going to become positive 4, plus or minus the square root. 4 squared is 16. Doesn't matter if it's positive or negative. As soon as you square it, it becomes positive. Minus 4ac, so minus 4 times 2. The a is 1. All over 2a, so all over 2. 2 times 1. So we get 4 plus or minus the square root of 16 minus 8 all over 2, which gives us 4 plus or minus the square root of 8 over 2. We're going to bring this guy up over here now. The square root of 8 is the square root of 4 times the square root of 2, so we can bring the 4 out. So I get 4 plus or minus 2 square root of 2 all over 2. The numerator is really 2 times 2 plus or minus square root of 2. What I did is I factored out a 2 off of each of these. This one's an obvious one, 4, 2 times 2. I did it so I can do that. And there's our 2 plus or minus square root of 2, which you guys had up here. There's 2 minus square root of 2, 2 plus square root of 2. And we wanted to know which one maximized. We have the picture. We're just proving this algebraically now. So what we would do on this one is obviously we can't make negative items. That's where you know when your domain comes in. So this is going to go 0 to 2 plus, minus square root of 2. And then 2 minus square root of 2 to 2 plus square root of 2. And then 2 plus square root of 2 to infinity. Okay, and we pick a number in here. So square root of 2 is, we're not going to get nice numbers here. I'm going to let you guys know that. We're really not getting nice numbers. 2 minus the square root of 2. I'm going to pull that up really quick. Is just more than 1/2. So we're going to use 1/2 here. Remember our test points? And value between these two, this is 3 point something and this is less than 1. So I'm going to just use 1 or 2. Let's use 1. And this is more than 3, but not 4, so we're going to make it 4. There's our test points. And we want to go back into our P prime. Because what I want to point out to you guys is we know that the values of each of those are 0. We want to know what's happening in between. So if I come back to this guy here and put in 1/2, well, this guy's going to be negative. This guy's going to be positive. So well, this is really 1/4, so this isn't being 3/4, so it's not even 1. So we'll subtract 1. That gives us 11. We're going to get a positive value. I put 1 into that mess. I put 1 in here. That's negative. Still going to get this. 12 minus 3 is 9. 9 minus 6, that's still positive. And if I put in 4, makes me think that negative should have been negative. Okay, I put in 4. This is going to become a very large negative. This is going to be even a larger negative, and this is positive. This is going to be larger though. 4 squared is 16. This guy becomes negative 48. This guy becomes 48, and we're left with negative 6. So this is negative. So no max min here, but there is a max here. Here's where the max happens at, and that's what we wanted right there. And we've proven that the maximum profit is at 2 plus square root of 2. I know we spent almost 10 minutes on that problem alone, and all we really had to do was look at the picture. But if you don't know how to do it algebraically, how are you going to get past that? So let's do one algebraically. Let's do another one. Okay, give me a little bit better numbers to play with as well. Suppose that r of x equals 8 square root of x and c of x is 2x squared, where x represents thousands of units. Is there a production level that maximizes profit? If so, what is it? So we're trying to maximize the profit again. So our profit is going to be revenue minus cost. So in this case, it's going to be 8 square root of x minus 2x squared. And then our marginal profit is going to be our marginal revenue minus our marginal cost, which is going to be, in this case, now keep in mind, this one here, derivative of the square root of x is equal to 1 over 2 square root of x, okay, d dx of this guy is this. So we're going to get 8 over 2 square root of x minus 4x. And to be able to maximize this, we want it to be 0 because we want them to be exactly the same. So I'm going to clean this up. 8 over 2 is 4, so I get 4 over square root of x minus 4x has to equal 0. And don't forget our critical points. Now on the other problem, we had to work for that critical point. We use the quadratic formula. We had to really work for it. This one here, keep in mind I have a radical in the denominator, which tells me that if x is 0, it's going to be undefined. So x equals 0 is a critical point, but we know we're not maximizing our profits at 0 because if you're not making anything, you're not making any money. But you're spending it, whoo, but you're spending it. Okay, so we need to just clean this up a little bit. So 4 over square root of x minus 4x equals 0. So I'm going to move this 4x over, this guy here over. So I get 4 over square root of x equals 4x. I'm going to multiply this side by square root of x over 4. That way it cleans up. And this guy also square root of x over 4. So these guys clean up and you're left with 1. But over here my 4's will cancel out. And I'm left with x square root of x. Now, before you guys go, wait, we can't do that. Oh, we can combine this. Square root of x is 1/2, and so I just need a common denominator. So 2 over 2. Bases are the same. You multiply the bases, you add the exponent. So we get x to the 3/2. So I have 1 equals x to the 3/2 power. It doesn't matter what I do to 1, 1 will always be 1, so x would have to be 1. So my other critical point is x equals 1. So we do our test. We can't make less than 0, so 0 to 1, and then 1 to infinity. Test points. Now, because we're dealing with the square root, I'm going to use perfect squares. So I'm going to use 1/4. And over here, I'm going to use 4. And it's only because that way I can do my square root stuff. So p prime of x, if I put 1/4 in, if I put in 1/4 into this guy, I get square root of 1/4 would be 1/2. 4 over 1/2 is 8. Keep that in mind. So I'll do the math over here. That's 8 minus, and this one here is going to be 1/4. 4 times 1/4 is going to be 1. So I'm going to get a positive number there. If I put 4 in over here, square root of 4 is 2. 4 over 2 is going to give me 2 minus, and 4 times 4 is going to give me 16. So I'm going to get a nice little negative value here. So I am maximizing at 1,000. Now, this is not just x equals 1,000. This is, I'm sorry, 1. This is x equals 1,000 units. So the question was, is there a production level that maximizes profit? Yes, it is. And so what is it? It's 1,000 units. 1,000 units will maximize profits. There you go. You cannot say x equals 1. You can't say when x equals 1 because they tell you these are in thousands of units. Okay, thousands of units. Make sure you pay attention to simple stuff like that. That can be really bad for you to miss something like that. So this is stuff that you've known how to do. They're just now talking about profit and revenue. Those of you guys going into business, this is a biggie for you. Okay, so minimizing average costs. The production level, if any, at which average cost is smallest, is a level at which the average cost equals the marginal cost. Example, if f of x equals x cubed minus 6x squared plus 15x, and x is in thousands of units, is there a value that will minimize the average cost? Now we're trying to minimize the average cost. And they told you got to get the average cost to equal the marginal cost. Well, they still haven't given us a number, so I don't want you guys panicking over this one. You should notice this, it looks a little bit familiar, that we're going to go back over here, this one here, that was this problem here. There you go. By the way, as I was starting to do this, I remembered that this here is 3.414, but this is in thousands. So if I was to move that decimal place 3, we're talking about 3,414 units. Sorry. So back to this guy. So x cubed minus 6x squared plus 15x, the average. So keep in mind, I want average cost to equal marginal cost. Well, marginal cost is the easy one because you just take that derivative. So you get 3x squared minus 12x plus 15. And we want that to equal our average. Well, since we don't know what that value of x is, but you guys all know how to take an average, this is going to be x cubed minus 6x squared plus 15x, all of this divided by whatever x is. If my average is 100 values, 100 units, then it would be 100. So if I clean this mess up, I get x squared minus 6x plus 15 equals 3x squared minus 12x plus 15. And we need to combine these two. Just like you would do any other problem, we got to set them equal to 0. So since this guy's larger, I'm going to move these guys over. So I'm going to subtract x squared, add 6x, subtract 15, subtract 15. So at this point, this side over here becomes 0 equals 2x squared minus 6x, and that cancels out. So I have 2x squared minus 6x equals 0. So I have an x on both of these, so I'm going to take one off. So I get left over 2x minus 6. So either x equals 0 or 2x minus 6 equals 0. Well, first of all, I'm going to point out that I guess you can minimize your, says the project smallest, okay, minimizing average cost. Yeah, I guess you can minimize your cost if you don't make anything, but you're not making money off of anything either. So we're going to kind of cancel out x equals 0. So we get 2x equals 6, so x equals 3. Now we want to just verify that this is actually going to minimize. So we're going to go through, we have 0 to 3, and then 3 to infinity. Test point, let's make this guy 1 and this one 4. And we're going to go back up here, just go ahead and use the derivative, the 3x squared minus 12x plus 15. So f prime of x. If I put 1 into this guy, if I put 1, now we're talking about this guy here. If I put 1 in, I get 3 minus 12, which is negative 9, plus 15 gives me a positive value. If I put 4 into that mix, I get 48, negative 48, so those cancel out. And I'm left with 15, which is a positive value. Wait, something went wrong. I got positive value on the other one. Was I supposed to get positive on the other one? We're not supposed to get positive on both of these. 16 times 3 is 48. 12 times 4 is 48. Okay, silly me. On both of these, we want to go back up to this guy here. This guy, it doesn't matter. This guy here, if I put 1 in there, I'm going to get a negative value. If I put 4 in, I'll get a positive value. And this does show that it minimizes it. It's a minimum. So at 3,000 units, I minimize cost. Now it's not maximizing profit, but it's minimizing the cost. Okay, so there you guys have it. That's the end of that one there. So both videos about 23 minutes long. Not too terribly bad. Okay, good luck on the homework.